After learning drawing the graphs and knowing the domain and range of the trigonometric functions, we come to a point where one trigonometric ratio's value is given and we are told that that trigonometric ratio of that particular angle, that angle lies in a particular quadrant. With this information, we have to find the remaining 5 trigonometric ratios of that angle which lies in that quadrant. So that takes us to exercise 3.2. So exercise 3.2, here we are given single trigonometric ratios and we are told that that angle lies in which particular quadrant, and we have to find the remaining 5 trigonometric ratios of the same angle. So now we have cos of the angle that lies in third quadrant is negative of 1 by 2. We have to find remaining 6 trigonometric ratios. So by the time when I wrote this, instantly I wrote sec also. Why? Because cos and sec are reciprocal ratios. If cos of x is negative 1 by 2, then sec of x is negative 2 by 1. Now from here we have to extract the remaining 4 trigonometric ratios. See, when we know sec, we can know tan also. And when we know cos, we can find sine also using the trigonometric identities. So I start with sine. We know that sine square x is 1 minus cos square x. This is taken from the identity sin square theta plus cos square theta is equal to 1. We know this value by this time. So it is 1 minus negative 1 by 2 square, and which is 1 minus negative square is positive, 1 square is 1, 2 square is 4, 1 by 4. So sin square x is 1 minus 1 by 4 is actually 3 by 4, but whenever we take out the square, we put plus or minus under radical. So sine of the same angle is plus or minus root 3 by 2. So sine of that angle is plus root 3 by 2 or minus root 3 by 2. How to know that? For that, see x lies in which quadrant? X lies in third quadrant. In third quadrant, only tan and cot are positive and remaining all trigonometric ratios are negative. So sine is going to be negative in third quadrant. So we have to discard the positive and we have to take the negative sign. So sine of that angle is a negative of root 3 by 2. So we got cos was given to us. We got sine, we got sec. So 3 of them are there. Another 3 we should find. So from sine and cos we can find tan, or using sec and that identity related to sec square theta is 1 plus tan square theta, we can find tan also. So I prefer ABCD. Okay, I prefer to use the identity. So we know that sec square theta or x minus 1 is a tan square x. So in one line itself we can find tan value. This is a negative 2. So negative 2 square. So what is tan square x? Tan square x I wrote here is equal to negative square is positive, 2 square is 4, 4 minus 1, so 3. So when we take out square, we put plus or minus. So tan x is plus or minus under radical 3. Square makes this root 3. Tan of an angle is either plus root 3 or minus root 3. Both of them is not possible. For that we should know x lies in which quadrant. We are told that x lies in third quadrant. In third quadrant, tan and cot are positive. So tan of this angle lies in third quadrant. So tan of that angle is positive. So positive of root 3. So we got this also. Now we want cot. Cot is just reciprocal of tan. So I am going for the E bit. So what is cot of the angle? Cot of the angle is reciprocal of tan, means 1 upon tan x, means 1 upon root 3. So we are left with only one trigonometric ratio, that is cosec. Cosecant of x is actually 1 by sine of x. Sine of x is a negative of root 3 by 2. So we'll write here 1 by negative root 3 by 2. So cosec or cosecant of x is negative of 2 upon root 3. So the final answer. Now the second question, we are given sine of x is a 3 by 5 positive and we are told that x lies in second quadrant. So I kept x in second quadrant, and in second quadrant sine and cosec are positive, rest all trigonometric ratios are negative. So we have to find other 5 t ratios. Once we know sine, we know cosec also. So cosec of the same angle is reciprocal of this, means 5 upon 3. Same sign, because sine and cosec, both of them are positive in second quadrant. Now when we know sine, we can find cos. Using the identity sine square theta plus cos square theta is 1. So this is A. Like we'll count for 6 t ratios. So C is cos square x is 1 minus sine square x. So 1 minus sine is 3 by 5. So it's a square. So this is 1 minus 9 by 25. So it is 25 minus 9. Cos of the angle that lies in second quadrant is negative, because cos is negative in second quadrant. So we will not take plus, we will take negative of 4 by 5. So cos x is negative of 4 by 5. The moment we get cos, we can find sec. Sec x is reciprocal of cos, means 1 by cos x, means negative of 5 by 4, because 4 by 5 is cos, so sec is this. Once we get this, after this we can find tan using sec and tan relation, or sine by cos. That's perfectly our choice. So this time I am finding tan x using sine x by cos x. Sine x by cos x. Sine of the angle, we are told that it is 3 by 5. Cos of the angle is negative 4 upon 5. We can cancel this, and we are getting negative of 3 by 4. And this is correct. Why? Because sine of that angle is negative. Sine of the angle if it lies in second quadrant tan is negative. Tan is positive in the third quadrant. So negative of this. Then once we get tan, we can find cot also. Cot of the angle is a reciprocal of this, means 1 by tan x. 1 by tan x is 1 by minus 3 by 4. So it is 4 upon minus 3, which is minus 3 by 4. So 1, 2, 3, 4, 5, 6. All trigonometric ratios of the angle is found. The third bit or third question of exercise 3.2 is cot of an angle is 3 by 4, and we are told that that angle lies in third quadrant. And remember, in third quadrant only tan and cot of an angle are positive. Rest all trigonometric ratios are negative. So let's find the remaining 5 trigonometric ratios. So the first one is given. We are finding the second one. When cot is given, tan we automatically know. Why? Because tan and cot are reciprocal ratios. So tan will be 4 upon 3, and you see both of them are positive. Then we will find tan is there. So we can find sec. We know that sec square theta is 1 plus tan square theta, one of the fundamental trigonometric identities. So it is 1 plus 4 by 3 square, means 4 square by 3 square. It's 1 plus 16 by 9, so 25 by 9. So sec of the angle is plus or minus under radical 25 by 9, so plus or minus 5 upon 3. Now sec of the angle is a positive 5 by 3 or negative 5 by 3. For that we should know where x lies. The angle x lies in third quadrant, and in third quadrant sec of the angle is negative. So we will not choose positive, we will choose negative, negative 5 by 3. So sec of the angle is negative 5 by 3. When we get sec, we can find cos also. Cos and sec are reciprocal ratios. So cos x is negative of 3 upon 5. Then since we know cot, we can find cosec. We know that cosec square theta is 1 plus cot square theta. Theta is x here. So cosec we want. Cot value is 3 by 4 according to the question. So 1 plus 3 by 4 overall square. So this is 1 plus 9 by 16. So 16 plus 9 by 16. This turns out to be 25 by 16. So what is cosec? Cosec x is, we are removing the square, so we have to put on the other side plus or minus under radical 25 by 16, means plus or minus 5 upon 4. Now cosec of x is a plus 5 by 4. or negative of 5 by 4. For that we should know where x lies. X lies in third quadrant, and in third quadrant only tan and cot are positive and all other trigonometric ratios are negative. So cosec of the angle which lies in third quadrant cannot be positive. So it is a negative 5 by 4. The moment we got cosec, we can write sine of x, because sine and cosec are reciprocal trigonometric ratios. So it is 1 upon negative 5 by 4, which is negative 4 by 5. So we got 1, 2, 3, 4, 5, 6 trigonometric ratios. The fourth question, we are given secant of the angle as 13 by 5. The angle lies in fourth quadrant. In fourth quadrant, cos and secant are only positive, rest all trigonometric ratios are negative. Whenever secant is given, we can find cos because they are reciprocal ratios. So cos of the same angle is going to be reciprocal of this, means 5 upon 13. When we know cos, we can find sine. So sine square x using fundamental trigonometric identity is 1 minus cos square x. So 1 minus cos square. Cos x is 5 by 13. So cos square is going to be 25. 5 square is 25 upon 13 square, means 169. So LCM of this 169 minus 25 by 169. So what is sine square x? That is going to be, this is 144. You see 9 minus 5, 4. So here this turns out to be 169, 25. Yes, 6 minus 2, 144. So here 169. So sine square, if I take out square, I'll write plus or minus under radical 144 upon 169. So it is positive or negative of 12 upon 13. Sine of the angle is positive this number or negative this number. For that, x lies in which quadrant? It lies in fourth quadrant. In fourth quadrant, sine of an angle is negative. So we will discard the positive one and we'll take it as negative 12 by 13. When we know sine, we know cosec too. Cosecant. Cosecant of the angle is a reciprocal of sine. So cosecant is negative of 13 by 12. Negative 12 by 13 is this. Then because we know sec, we can find tan. See, since sec square theta is 1 plus tan square theta, so tan square theta is going to be sec square theta minus 1. We are told that sec of the angle is a 13 by 5. So its square is this minus 1. So it is a 169 by 25 minus 1. So here minus 25 by 25. So this is 144 by 25. Tan square is this. So what is a tan x? Tan of the angle is plus or minus under radical 144 by 25, which is plus or minus 12 upon 5. 12 upon 5. So it is positive or negative. X lies in fourth quadrant. Fourth quadrant only cos and sec are positive. So tan is going to be negative. So negative of 12 by 5. When we know tan, we know cot also. So cot of the angle is a reciprocal of this. So negative 5 upon 12. So 1, 2, 3, 4, 5, 6. So these are the 6 trigonometric ratios. Question number 5. We are given tan of an angle is a negative 5 upon 12. And we are told that x, the angle, lies in second quadrant. In second quadrant, only sine and its reciprocal cosecant are positive, rest all are negative. We have to find the remaining 5 trigonometric ratios. So one trigonometric ratio is given. The next trigonometric ratio is very quick to find. It's reciprocal. Tan's reciprocal is cot. Cot of the angle is negative 12 upon 5. If we know tan, we can find sec too. So sec square x is 1 plus tan square x. This is using the fundamental trigonometric identity. By this time we are given tan. So 1 plus negative 5 by 12 square. So 1 plus negative square is positive, 5 square is 25 upon 144. So on taking LCM, we get 144 plus 25 upon 144, which turns out to be 169 upon 144. Sec square is this. In that case, what is the sec of that angle? It is plus or minus under radical 169 upon 144, which is positive or negative of root over of 169 is 13 and root over of 144 is 12. So it is 13 by 12. Now, sec of the angle is positive this number or negative this number. For that, we should know x lies in which quadrant? X lies in second quadrant. And in second quadrant, only sine and cosec are positive, rest all are negative. So sec is negative. So we'll discard the positive and the answer is negative of 13 by 12. The moment we get sec, we can write cos 2. Why? Because cos and sec are reciprocal ratios. So cos is a secant of x, which is 1 upon minus 13 by 12, which is negative of 12 by 13. Now, since we know cot, we can find cosecant. Cosecant or square cosec theta is 1 plus cot square theta. And here we are told cot is, cot is negative 12 by 5, negative 12 by 5 square, which is 1 plus negative square is positive and square of 12 is 144, square of 5 is 25. When we take LCM these all, we'll get 169 upon 25. So cosecant square of the angle is this. In that case, cosecant of the angle is plus or minus under radical 169 by 25. 169 square root is a 13, 25 square root is 5. Now cosecant of the angle is positive or negative. For that, x lies where? X lies in second quadrant. Second quadrant cosecant is positive. So we will discard negative 1. Cosecant of the angle is positive number 13 by 5. Then we should find sine. So the moment we get cosecant, we know that cosecant and sine are reciprocal ratios. So sine is 1 upon 13 by 5 means 5 by 13. So these are the 5 trigonometric ratios. Number 6 question. We are supposed to find the values of the trigonometric function. We are given sine of 765. How to get this? We have to see for 360s which multiple is very close to 765. So 360s which multiple means 720 is very close to this number. So we can write this as sine of 720 degrees plus 45 degrees. See, 720 plus 45 is 765. But what is 720? 720 is 2 times 360. 2 times 360 means 2 pi. So sine of an angle 2 pi plus 45. 2 pi plus 45 means where this angle is going to come. This angle is going to come in, you see, pi, and this is 2 pi. 2 pi plus an angle means it is going to come in first quadrant. In first quadrant, all trigonometric ratios are positive, and this is the no change line. No change line means a sine remains as sine. So value of sine 2 pi plus 45 is going to be sine only. Sine of 45 degrees, which is 1 upon root 2. Now the second one, 7th question in the exercise. It is, we are supposed to find a cosecant of a negative of 1410. So remember that sine of negative x, sine of a negative angle is negative of sine of that angle, and cos of negative of the angle is positive of the angle. Sine is odd function, remember, so it is negative. So sine, tan, cot are odd functions. Cos, sec are even functions. So even functions will become positive. This remains negative. So sine's reciprocal is cosec. So this is also odd function. So sine of cosec of negative angle is negative of cosec 1410 degrees. Negative of a cosecant of 1410 can be written as 1440 minus 30 in degrees. So this is negative of cosecant of 8 pi minus 30 degrees. Where is 8 pi? 8 pi is somewhere it will come to positive x-axis, but it is minus 30. Minus 30 means it comes to the fourth quadrant. In fourth quadrant, cos and sec are only positive, rest all are negative. So cosecant of this angle is negative. So it is negative of negative cosecant, but it is 8 pi minus 360 means it is about x-axis the angle. So this is the no change line. So cosecant remains cosecant, cosecant of 30 degrees. Negative of negative is positive. So cosecant of 30 degrees. We know that sine 30 is 1 by 2. So cosecant of 30 is a 2. We are supposed to find the value of tan 19 pi by 3. How to find this? We have to write this as a combination of angles, like with respect to pi by 2 change or with respect to pi change. So that with respect to pi means x-axis, if it changes, tan remains tan. But if this angle is written with respect to pi by 2 means y-axis, then tan will become cot. So this how to write? So here you separate out pi by 3 and then think to 3 what will you multiply so that on adding or subtracting to pi we get 19. 3 into 6, 6 3 is 18. So we can write here 6 pi and here we have to put plus. Why? Because 3 6 18, 18 pi, 18 pi plus pi is 19 pi. Fine. 6 pi, pi means with respect to x-axis. So no change, means a tan remains a tan, that's fine. So tan of pi by 3, but this angle is in which quadrant? So this is a 6 pi, means a 3 rounds about the positive x-axis, and this angle comes in first quadrant. In first quadrant all trigonometric ratios are positive, so this comes as tan pi by 3. Pi by 3 is 180 by 3 means 60. Tan 60 is a root over of 3. Question number 9. Question number 9 is we are supposed to find the value of sine of negative 11 pi by 3. Remember, sine of negative angle is negative of sine of that angle, 11 pi by 3. Now negative, let it be. Now work out for sine. This we have to represent in terms of pi means x-axis or in terms of pi by 2 means y-axis. Sine of, write this pi by 3 first, pi by 3. Now here I should put something so that when I multiply this and add pi I get 11. So we can go for 3 pi. See, 3 into 3 pi is 9 pi. 9 pi plus 1 is a 10 pi. So 3 will not work. So we can go for 4 pi. 3 into 4 pi is 12 pi. 12 pi, if you put minus here, we will get 12 pi minus pi means 11 pi by 3. This is how we'll write this. So 4 pi means what? About x-axis, about x-axis. This is a 2 pi and now it is 4 pi. 4 pi minus pi by 3. So it is plus pi by 3 means you jump to first quadrant. Minus pi by 3 means you are still in fourth quadrant. So this angle belongs to fourth quadrant. In fourth quadrant only cos and sec are positive. Any other trigonometric ratio is negative. So this is negative of negative. But the changes are done with respect to x-axis. So sine will remain sine. If the change was occurring with respect to y-axis, sine would have converted to cos, but it is with respect to 4 pi, means x-axis. So sine will remain as sine and here pi by 3. Negative of negative is positive. Sine of 180 by 3. 180 by 3 is a 60. Sine 60 is root 3 by 2. Then the last question of this exercise is number 10. This is a cot of negative 15 pi by 4. Sine, tan, cot, cosec are odd functions, due to which cot of their negative angle is negative of cot of that angle, means 15 pi by 4. So negative will stay, that's okay. Start the bracket, cot of. So this we have to split in form of with respect to pi by 2 or pi. So first pi by 4. Once we write pi by 4, our target is 15. So here if I go for 4 pi and put a minus, then 4 4s is 16. 16 minus pi. So how to write this in form of this? That with practice you will get. But every time separate pi by 4. Then you can figure out what can be here and what symbol comes here. Now the change is occurring with respect to x-axis, so cot remains cot. Where is this angle? This angle is in the fourth quadrant. In the fourth quadrant, cot is negative. So here we get negative of negative cot of pi by 4. Pi by 4 is 45. So here negative of negative is positive. Cot 45 is 1. This completes the exercise 3.2 of the NCERT class 11th maths textbook.